Good morning, everyone. I hope you're all or afternoon, or possibly even evening, everyone. Hope you're all having amazing days. Hope everybody had a fantastic weekend. Nice little cool front coming through here. Today we're going to be talking about something, or talking about kind of pulling everything that we've learned in the past 3 units together. Now, I have told you that this unit specifically is only 4 lessons long. This is the fourth one. So really, this is about it. So we're going to get this thing settled up, scored up, set on its way, and we'll take one step farther after that. So on the topic of putting it all together, it says find all angles theta. Now let's talk about how to actually read this, because there's only 4 questions on here. So let's talk about how to read these. It says find all angles theta that satisfy the equations 0 to 360 and 0 to 2 pi. That means that theta is somewhere in between 0 to 360 and 0 to 2 pi. It says list your results in degrees and radians. So see that degrees and radians. I'm going to make sure I list both. And then obviously do not use a calculator, so we won't. So when you see that do not use a calculator, that might be a good symbol or a good little clue to you that you're going to need a unit circle. So I'm going to keep that handy off to the side here, and let's get started on this. Best part of waking up. So we've got the cosine of theta is negative square root of 3 over 2, and tangent of theta has got to be greater than or equal to 0. Let's forget about this for a moment. Let's just go with the cosine of theta equals the negative square root of 3 over 2. Now, you remember that the first thing I need to do is come up with alpha. So I'm going to forget the fact that this is negative, and I'm just going to come up with alpha. So where will the cosine value be the square root of 3 over 2? Remember, I'm just looking at these angles right here because I'm forgetting that they're negative. So between 30, 45, and 60 degrees, where will my cosine value be the square root of 3 over 2? Well, it's going to be at pi over 6 and 30. So I'm going to write that down. 30 degrees or pi over 6. Okay, and then, again, I'm forgetting this tangent for right now. And then what I'm going to do is I'm going to place it in the appropriate quadrant. So I'm going to look at my cosine and see where is cosine negative. Well, cosine is negative here and here. All right, and then I'm going to look at where is, so I've got 2 quadrants that cosine can be negative in. And then they add on this one extra little tidbit, and it says that tangent of theta has got to be greater than or equal to 0. It means tangent of theta has got to be positive, right? Where is tangent theta positive? It's in quadrant 1 and in quadrant 3. So you see what I kind of do here is mark off the quadrants that these things are valid in. And then the x marks the spot. This is where they meet up. So the only quadrant where cosine is negative and tangent is positive, the only time that that ever happens is down here in quadrant 3. So here's your angle. This guy right here is 30 degrees, or pi over 6. So what's that angle? So I'm going to have my theta is going to be either 210 degrees, or if you take pi and add pi over 6, the pi would be 6 over 6 to make it 1. Add pi over 6 and you're at 7 pi over 6. Now, my goal is for you to not to have to use this all the time, because if you can just remember these coordinates, these 3 coordinates, and which angles they go with, then this is going to be a piece of cake. 45 is easy to remember because it's all the same. If you can remember that 30 is the square root of 3 and 60 is 1/2 for your cosines, the rest of it can kind of fall into place. All right. Let's move on. Number 2, sine of theta equals 0 and cosine of theta equals -1. Sounds a little fishy to me. Sine of theta equals 0. Where in the world would sine equal 0? Sine is my y value on my unit circle. Where would my y value equal 0 at? Well, let's think about that. Theta is, think about your unit circle. Now I'm not going to use mine for a moment. I'm just going to try and visualize this thing. If you want to think about your unit circle, right? You got a little picture of a circle. Where is your y value 0? Well, it's going to be at 0, right here at 180, right here at 360. Let me write that down. 0, 180, and 360 all degrees. Okay. What about cosine of theta being a -1? Where is your x value -1 on your unit circle? Try and visualize it here. Your x value is -1 at 180 degrees. And that's the only place where that happens. Now, since that's the only place where this happens, and this says this and this has to happen, then that means that my only answer here is 180 degrees, or if I'm in radians, pi. See, sine is 0 at 0, pi, and pi over 2. Or, excuse me, 2 pi, right? 0, pi, and 2 pi. But I'm looking for where cosine is also -1. So that restricts us down to one answer. This is my answer. So it's not too crazy of a lesson today, I don't think. It's just talking about restrictions. Now, last week, we talked about having your, we talked about solutions, but they weren't restricted like these are. We talked about solutions, and last week, this would have been your answer for just this part right here. This would have been your answer, 0, 180, and 360. But for now, because of this new thing, we're going to restrict it to just 180 degrees. So you can think of this section as just adding on one more restriction. All right? Now this next part says to use a calculator. So I'm going to get my calculator out. It says use a calculator to find all of the angles that satisfy the equation within the given interval. This is going to be extremely important, within the given interval. Alright, so secant of theta is 3.19. So just like I did before, I'm going to rewrite that thing as the cosine of theta is 1 over 3.19. I saw a lot of people struggling with the decimals, with the fact that it was a decimal. Please don't let that trip you up. The reciprocal is still 1 over 3.19. That's not going anywhere. Okay? And then let's come up with our reference angle. Please do not forget your reference angle. We have the inverse cosine of 1 over 3.19. Now the question is, what is this in? Is this in degrees or is this in radians? Because if you just look at the secant, it doesn't say. It doesn't say whether it's degrees or radians. It just says secant is 3.19. But if you look at the restriction between 0 degrees and 180 degrees, now it's in degrees. Well, fantastic. So I'm going to put is equal to. I'm going to grab my handy dandy calculator. I'm going to clear it out, go to mode, make sure I'm in degrees. And then I'm going to hit secant cosine of 1 divided by 3.19. 71.7, and since we're rounding to the nearest degree, we'll call it 72. 72 degrees. Okay, now let's think about where this thing is going to happen. Says that secant or cosine is positive. Where is cosine and secant positive? Well, that's here and here. But our restriction is between 0 and 180. So that kind of cancels out this bottom part, and I've only got one answer. This reference angle is 72 degrees, so that means that theta, since it's in the first quadrant, is 72 degrees. So the restriction canceled out that second answer that I would have usually had. Okay? Last one here. Again, these were probably one of the more missed questions, so I want to make sure and go over another one of these. It says P is a point on the terminal side of theta. Find theta for 0 to 360. That's in degrees, obviously, for this given point. So P is a point. First thing I'm going to do, like all good mathematicians, we're going to draw 5 comma negative 9. This is 5. This is negative 9. Alright, 5 comma negative 9. And it says find theta. Now this one was a little bit more entertaining because now we're trying to come up with this angle. Well, if that's my angle, that means this is my reference angle, right? Compared to this reference angle, what two sides of the triangle have they given me? So I'm going back to my right triangle trig. Here's my hypotenuse. Compared to this angle alpha, this is the opposite side. This is the adjacent side. Which trig function deals with the opposite and the adjacent? Well, that's tangent, isn't it? So I could say that the tangent of theta is negative 9 over 5. Opposite over adjacent. So alpha, the little alpha guy in there, is the inverse tangent of 9/5. Again, disregard the fact that it's negative. I'll say that again and again, disregard the fact that it's negative. And you grab your calculator and you get alpha is 61 degrees once we round. That means this angle is 61 degrees. So how do I find theta? I take 360, I subtract 61, and I get 299 degrees. So I would like to point out just a few things on this, and then we'll call it a wrap. On this type of a question, when it gives you a point and you're trying to find theta, you're going to have to use your inverses, obviously. Now, if it ends up being one on the unit circle, you don't have to use a calculator. You can use a unit circle for it. But if not, and if it comes up to this point here, you will have to come up with theta on your own. So that's going to be some type of inverse function, some type of inverse trig function, setting up alpha, and then either adding or subtracting that from your circle. Okay? So let's keep focusing on this for a little while. When you get back, we are going to go over some questions in class.